it is recording. Well, since these things have numbers, I'm pretty sure it's actually recording. It doesn't hurt to double check it. So go to the D drive. And these things are both, the video file doesn't seem to be increasing in size. Let me check. Yep, they're both growing, so I'm suspecting it's working. All right, so with that out of the way, and I apologize for using up 15 minutes to set this up. All right, so we go to Moodle. And your sign in is W followed by 7 digits and then your usual password. My sign in is a little bit different. All right, here we go. Okay. Nope. So first thing first, we'll go over the syllabus today. That's the first thing. At some point, I'm going to pass a roll sheet. If you are enrolled or on the wait list, you definitely want to put your initial next to your name so that I know that you are here in class today. I'll explain the importance when we go over the syllabus. This is the website. You will see something similar to this, but not exactly the same. What I'm going to do next is to pretend to be a student. So I'm going to switch my role to a student role. So this way you can see exactly what you should be seeing on your end. And I can zoom in just so that everything is easier to read at this point. So you will see that all of the other resources is not really accessible, it's not clickable, because it is not available unless you achieve a required score, which is 100%. In interactive syllabus. So that's the first thing you have to do, is to go through the syllabus, which is kind of like a quiz, but it's not. Okay, you will see why I say that. I have already started the attempt like a while back, just to test it. So I'm just going to continue my last attempt. It does not really count for your grade. It is really just to make sure that I have your acknowledgement of the syllabus and its content. The first part talks about this particular section of cisp360. How many sections do we have at ARC? Is it like 4, 5 sections of cisp360? Or 3? Yeah. 5? 4? Okay. We used to only have 2. Okay, so we have already doubled the offering of cisp360. So this particular one has a meeting time of 9 to 10:20 a.m. for the lecture portion, and from 10:30 to 11:50 we have the lab portion. The lecture portion will be focusing on mostly concept stuff, and then the lab portion will focus on hands-on stuff. Okay. Now, when you sign on to this class, the schedule is already scheduled like this. So I'm counting on you guys to be available for the second half of this class during the lab time. Okay. In other words, I'll be teaching important stuff during that time, and you really should be here during that time, or at least until it is over, until the important stuff is over. Okay. Are there any questions about the scheduling of this class? This is the only fully face-to-face offering of all 4 classes, and I personally prefer all face-to-face for my classes. So when you're done with this, you just click one of the 2 options. This is the correct class and correct section. I intend to stay in this class. Or if you are thinking that you should be in an art class, this is the wrong class, you can click the second option, and I can drop you from this class, saving you some trouble. Question number 2 is not really a question, it's just information about me. You can just call me Tack, that is perfectly okay. My email address is drtack2015spring@gmail.com, and as the name implies, I have a new email account every semester. That way it's easier for me to keep track of student email. I don't have all the different email from different people all at the same spot. My office hours are from 8 o'clock to 9 o'clock, Monday to Friday. So that makes it pretty easy to remember. It's right before this class. So if you have any questions that you need to ask, you can go to my office, right before this class, and I should be there. Are there any questions about my office hour? Questions? Okay. My office is number 7 in Liberal Arts 133. Does everybody know where to find Liberal Arts 133? It is one aisle to that side, okay? And it has a number, LA 133, on the door, and that's the division office for the entire business and computer science division. So my office is number 7 within that room. If you need to arrange for another time to talk to me, go ahead and send me an email so we can arrange for a different time. I'm on campus quite a bit, okay, so if you need to talk to me some other time, that usually can be arranged. If you're sending me any email, be sure to indicate your name and also which class you're in, because I get a lot of email messages saying, when is the homework due? Which homework? Which class are you in? And then the name, is going to be something that I cannot recognize. It's not an actual name. So, so I have to go bounce it back, to the person and ask, okay, so who are you and which class are you in, so I can answer your question. First day of class or orientation. This is the first day of class for this particular course. Any absence of the first day of class or orientation is sufficient reason to get dropped. This is a hyperlink. You can read the actual linked document. Be sure to attend the first class or orientation of your classes. I don't think you guys have any issues with this one, so I will just go ahead and click I acknowledge the district regulation. If you are, okay, and I'm not talking to you guys physically here, if you are watching this video at home thinking that I'll be okay just from watching the YouTube, then the answer is no, it is not okay. There are people like that, okay? Trust me, there are people who just who wants to take this class, which is face-to-face, in an online fashion. It's not gonna work with this class. Excessive absence is defined by Los Rios regulation to be 6% or more of absences. So if you skip all the mumbo jumbo here, we can go to the calculation. Each class session has 80 minutes. I only count the lecture portion. And the lecture portion has 54 hours for the entire semester. So that means each class accounts for 2.47 something percent of the entire semester. So the first absence is not going to be excessive. The second absence is not going to be excessive. The third one is excessive, because the third one will bump the absence ratio to more than 6%. That translates to people can miss 2 classes with no excuses and still be in the class. The third one will bump you out. Is that okay? All right. So let's move on. And the way I keep track of this is to take roll. So I have my roll sheet already printed. And sometimes I forget to pass the roll sheet, which means on that day everybody is present. So I'm going to pass this at this time. This is a good time to do it. I usually don't do it at the very beginning of the class, just so that people have time to park and walk in here. So are there any questions about the excessive absence policy? Yep.
So if you miss lecture and lab, is that 2 absences, or is that
No. I usually don't take roll, during the lab. Okay, so lab is kind of like, if you miss it, it's not. I'm not going to repeat that materials, and sometimes it cannot be recorded. So I would at least attend the first half hour or so, of the lab time. Especially if I have something to demonstrate. I usually would say that during the lecture and say, okay, I got something to demonstrate in the first part of the lab, so you might want to stay at least for that portion. Okay. But I don't take roll during the lab time. Excused absences. Okay, certain excuses are acceptable, and in fact, the college, is mandatory that I have to accept these excuses. The first one is health. The thing about the using health as an excuse is it has to be the student's own health. It cannot be the health of somebody else. Now, I have kids, and I know many people have kids too, and sometimes when your kids are sick, you have to stay home and watch the kids. So that's kind of a bummer. So it depends on, I can do this on a case-by-case basis. In other words, if you can show me a doctor's note of your kid, getting sick, I can consider excusing that one as well. But on paper, only your own health, can be used as an excuse with a doctor's note. What if you don't have a doctor? On campus, if you go to the administrative building, there's a health center. The nurse at the health center can write those notes as well. So if you're feeling sick while you're on campus, you can go there and get a nurse's note, and it will work out for this as well. If you're in the military and you have a notice and you have to do something and you cannot attend the class, with a copy of the duty notice, you can also be excused. And the same thing for jury duty. So all of these three are reasons where you can get an excused absence. The next one is about cheating or academic dishonesty. I define dishonesty kind of in a fairly broad way. It occurs when a student attempts to show possession of a level of competency, knowledge, or skill that person does not possess. Okay, that's basically it. You can also look at it in the flip side, from the flip side of what is academic integrity. It basically means the grade of a particular assessment of a particular student should reflect the academic performance of that student, and only of that student. Okay, it's not of somebody else. At the time of the assessment, following all the rules of the assessment as well as general rules already discussed in the syllabus, and only using resources that are permitted by the instructor. And right here, I can tell you, all of the exams of this class, the first, the second, and the final exam are open book and open notes. So you might want to take notes during class to help yourself, as the quote-unquote cheat sheet, but it's not really cheat sheet because you're allowed to use it. I have not decided yet whether your exams will be online or not. Okay, so that part I have not determined. It depends on the class size. If the dean says, I have to let everybody in, then I have to make it on paper, because not everybody will have access to a computer. You can see all of those people sitting in the back. Okay. On the other hand, if I can keep the class size small enough to guarantee each person has a computer in front of that person, then I can make it an online test. Okay. Now, online does not mean it is off-site. It simply means you can use a computer in the lab during the exam. Are there any questions about that portion, using resources that are permitted by the instructor? But regardless of whether it's online or not, it's going to be open book, open notes. Okay? If you would like to use a resource that is not permitted explicitly by the instructor, me, you should go ahead and ask it first. Ask me whether it is okay to use that resource before using it during the exam. Yep, go ahead.
You're saying that it's open book, but
Yep.
when I went on to the schedule and everything before to get my books and stuff, you don't have anything
I
required?
do not have any textbook specified for this class. I type my own notes.
Okay.
So that's sort of my text.
Your open book?
Yeah. But if you find other books that you find to be helpful, useful, you can bring those as well.
Okay.
You can wheel in a stack of books if you want to. Yep.
Do you have any recommendations for books?
I don't really. I personally learned C from online help and C++ also from online help.
Okay.
So I don't really know any good textbook for learning C and C++. If you search online, there are plenty of free resources. But if you'd like to read a book, I suppose you can go to Amazon and just look for C++, and look at the rating of those books and find one that you think will work out for you. So, okay here. Student rights and responsibility, not directly related to this class, but I think every student should read this document. I know most people do not want to read it because, it's just telling me, what I'm not supposed to do on campus and stuff like that. But you know what? It also tells you what your rights are. okay? And I think, you should read about your rights as a student on this campus, okay? It tells you what you can do on top of, what you cannot do. Okay. Moving on, classroom behavior expectations. The one thing that really bugs me most would be disruptive behavior, okay? Things that can distract the entire class and basically stop other students from paying attention and stuff like that. So that's the big no-no. And that reminds me to turn off my own cell phone, or at least turn off the ringer. And I have not programmed this one yet to turn off the ringer. A good app for Android phones is called Tasker, and Tasker allows you to set up your phone to turn off the ringer during certain times, and it will turn it back on automatically. Because one problem that I have is I turn it off, and then I forget to turn it back on. And then all my, all the people who want to contact me will be mad because I don't answer the phone or answer the text, right? So, Tasker is a little app that can be helpful for that. Tasker is not free, but it can do a lot more than just turning off your phone at a certain time of the day. One big problem with many of my classes is chatting during the class. I can understand a certain level of chatting is not really a big deal. Like you run out of binder paper and you just want to ask your neighbor and see if your neighbor wants to give you an extra sheet of paper. I can understand it. It's not a problem. It is the habitual type of chatting that is problematic. Okay. Interruption, I don't want it, but sometimes I can understand the enthusiasm of people wanting to participate in the discussion. Okay, so just kind of raise your hand so I can just kind of do a, how do you call it? I was about to say round robin, because that's kind of like a computer science term of saying, okay, here, 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 and here. But, just let me kind of do the coordination, and then you can have your time to talk about, stuff that is related to this class. Mobile devices, I talked about that one already. Just turn it off or put it on silence mode. That's okay. Are there any questions about all of these items? But these are just examples of things that can distract other students. Okay, so there may be other things that I am not covering here that can still be distracting. In this classroom, and also all of our classrooms here, you can see a big sign that says no food, drinks, phones, or kids. Okay. In this classroom, because we all have computers in front of us, that policy is actually strictly enforced. If you need to eat or drink something, you can step out of the classroom or wait until we have that break between the lecture and the lab. That's fine, okay? Or if during the lecture you just really need to go drink something, just walk outside, drink, and then come back inside. It doesn't bother me that much. Please come to class on time, because walking in late can distract the class as well. I do not lock the door. Okay, I try to make sure that the door is still open, but it is distracting to the rest of the class. Is parking okay today, or is it really bad?
Bad.
It's bad? How can it be bad? We have a multi-story parking structure.
You just gotta walk a little farther.
Exactly, so you have to plan for it, right? Just have to plan for the extra time that you have to walk. Okay. If there is a class, prior to this one, you want to let everybody out of the classroom first, because they have to get out eventually. Okay, so just let them out first before you come into this classroom. And I'm just going to click this here. How to attend lectures. Why would I spend or waste time to talk about how to attend lectures? I mean, obviously, you guys have attended lectures before. Well, have you attended lectures where everything is recorded? For the most part, most of the time. Okay, so does that replace you taking notes or paying attention in class? No. Okay, so let's just say that I slept through a lot of my own classes. Okay, so I'm just going to use myself as an example. So I'm just thinking, since the professor is recording everything, I'm just gonna doze off during class because I was, I went to bed way too late last night. I just could not pay attention. Okay, what's gonna happen at the end of the lecture? I woke up, I go to YouTube, I find the lecture that is recorded, and I replay it. Right? How is that different from you guys paying attention like what you're doing right now? How is it different?
If you're confused about anything, you're gonna get help at the moment.
Exactly. The interaction part is the most important part, I think, in a lecture. And that's why I personally like face-to-face lectures. Because I can look at you guys and sometimes I can tell right away without anyone raising the hand, okay, I can explain this in a different way. Okay? But with an online class, I cannot do that. Okay? Until someone send me an email and say, or discussion board say, I have no idea what passing by reference means. Okay? Then I can only at that time I can tell, okay, there's a question about that. But in a class like this, you guys can just raise your hand and say, I'm not really understanding, what is passing by reference. How is it related to passing by value? Then I can just go over that again. So it's more interactive. The one good thing about recording my lectures is you can freeze, you can pause it, and then you can just copy the code at the time when you're watching the video. So that means all the details you don't have to copy. Okay? If you cannot write as fast as I can type, don't worry about it. Focus on the concepts, okay? Focus on why I'm doing what I'm doing, not exactly, all the details. Okay? Are there any questions about that part? I went to college at the worst possible time of technologies. I went to college, after chalkboard and whiteboards are popular, and before projectors, became, popular. So we had overhead projectors. Does anyone know what is an overhead projector? Okay, what does it look like? I think we might even have one of those things here. Okay, it's just a little light table with a lens to project an image, right? And many of my professors would prepare the material ahead of time. You print those things on what we call transparencies, which is really just a sheet of plastic with your black or colored text on it. So the professor would slap a sheet on it, talk about it like that, and then put it off and slap another one on it without recording anything. So the class would be frantically trying to write everything down. Now, if the professor was writing everything on a whiteboard or chalkboard, it's not as much of a problem because that will take time too, and that will leave enough time for students to copy everything from the chalkboard or the whiteboard. But if it's on the transparency and it's done ahead of time, it's really tough to to keep up with the pace, especially when there's a lot of code, a lot of program code on it. It becomes impossible. And it is not distributable because the professor doesn't have a PowerPoint presentation and just go ahead and download it from the web. No, the web was not even that popular at the time. So you guys are kind of lucky in a way. One thing that you can also do is when I start on a particular topic, just mark the time. That's all you want to do on a sheet of paper. Mark the time and say at 10 o'clock, Tag starts to talk about passing by reference. Okay, that will give you a reference when you go to the YouTube recording. You will know, okay, in about an hour into the recording is that particular topic. It makes it so much faster to locate a particular topic because otherwise you have to watch it from start to finish, which is going to take a lot more time. Hey, grading standard. I'm going to skip a portion of this. I went through this yesterday, so. Okay, I'll just kind of show you the scheme here. So we have the usual A, B, C, D, F descriptions. Okay, I'm hoping this is not surprising to anyone in this class. Okay, and then we have A, B, C, D, F, but in the context of working. Okay, so for each particular grade, I have a statement that basically says, okay, if you are getting quote unquote an A for what you do at work, it means whatever you're doing, whatever you're delivering is surprisingly good. Your boss is impressed, your customer is impressed. It's like, wow, I did not know you can do something like this at this level of this quality. Okay? But since not everyone has worked before, I just decided maybe this is not the best way to explain what is A, B, C, D, F. So I have this last section here that talks about how to grade a product. How many people have not shopped at Fry's? Okay, good. Okay, so you usually buy some technological stuff, from Fry's. We know I know what you guys buy from Fry's. So let's just take a hard drive as an example here. So let's just say that you went to Fry's. It was on the paper. You got a good deal. You got a drive. You now installed it on the computer at home. You would probably rate that drive with an F if you installed a drive and it did not work and it smoked your power supply and your motherboard. Would anyone argue that that drive deserved a grade of F? Okay. What about a D? A D means you install the hard drive and you notice it is noisier than most of your other hard drives. And even though the hard drive is rated at a certain MTBF, or mean time between failure, it failed way before that. Okay, so it worked for a little bit of time, but the quality is just not there. That's a D. Okay, it's basically substandard work or product in this case. A C means average. Okay, nothing really to write about. You install the drive, it has about the average amount of noise and vibration, and if you install like 50 of these drives, the average of the 50 drives will fail at pretty much right on the mark at the rated MTBF, mean time between failure. That's a C. Okay, a C really basically means just barely passing the expectations, meeting all the expectations. A B means you install the drive, and you notice this drive seems to be a little bit more quiet than the average drive. And when you look at all the 50 drives that you install, when you look at the average is better than the MTBF, the rated MTBF. So it's better than average, but it's not really, it didn't take you by surprise, okay? You just kind of go like, well, that's good. And A means you install the drive and you are just surprised by how quiet the drive is. Okay, you double check the power connection and say, is it really powered up? Okay, so that's that's quality. And when you look at how much time it takes for a drive to fail, each and every single drive that you install passes that mark of MTBF. That is above expectation. Okay, that's basically a drive that deserves a grade of A. So are there any questions about what A, B, C, D, F mean in the class? Okay. All right. So you definitely want to read this part here too, because it talks about how grading translates in the class setting. Okay. In this class, when I translate your score at the end of the semester from numbers to letter grades, this is the way I do it. And to summarize, these are the thresholds. So 12.5%, 37.5%, 62.5%, and 87.5% are the thresholds to get a D, C, B, and A respectively. So it's not the 60, 70, 80, and 90%. It is really, just all the way across from 0 to 100%. Does that really mean this class is super duper easy? I mean, I just need 37.5% to pass this class. I mean, it has to be really easy.
What kills me is that your C is so low, but your A is so high. The gap between the two is enormous. Is it really, really hard to get an A?
Well, I would say, it's about the same as other classes. I think there are certain websites that collect statistics of the distribution of A, B, C, D, F of classes. That's actually public knowledge. You can actually go to any college and ask for that statistics. Okay, you cannot ask for individual grades of a person, but you can ask for statistics. And I look at my classes; they have the same distribution as you see most of the UCs. So the distribution of A, B, C, D, F are pretty much about the same. In other words, it doesn't make this class any easier. Assessment activities, where are those points coming in from? 20% of those points come from homework assignments, and that's not really a whole lot. 20% comes from your first exam, which is usually about 1/3 through the semester. Another 20% comes from the second exam, which is about 2/3 through the semester. And 40% comes from the final exam, which is for the last exam that you have. It's comprehensive. With a programming class, it's pretty hard to have non-comprehensive exams, okay? Because everything that you learn new would be based on stuff that you have already learned. So that's why it's basically all comprehensive. But the focus can be shifted. I can focus on more of the later material in the final exam. All right. Well, if you remember this one and remember the previous one, that means someone can ace the final exam and pass this class with a C without doing anything else. Okay. I'm not saying this as a challenge, so do not take it as a challenge and say, I'll be the first one that can do this, okay? I'm simply stating the number of points. Until the end of the semester, there's still a chance to pass this class. I think that's probably the most important message is, until the very end, there's still a chance. However, for people who may not be doing well in the first or the second exam, they might need to catch up quite a bit in order to get a good score in the final exam. But the chance is still there. The probability is still there. Okay, and this is the schedule of the topics. I usually go, just roughly by this schedule, and I'm hoping this semester by shifting more of the hands-on discussion to the lab time, I can finish most of these topics. The final exam is at the bottom here. It is on May 18th on the Monday, and the time is from 8 to 10 a.m. So make sure you remember, on the final exam, it is starting at 8 o'clock and not 9 o'clock. Okay, every semester I have people doing that, okay, because the class starts at 9 o'clock. Many people think, oh, okay, the final exam is going to start at 9 o'clock. No, the final exam starts at 8 o'clock. So be sure to be here an hour earlier than usual. So after you click all the acknowledgements, you can go to click next, and it will ask you to confirm that you are ready to submit all and finish. So right here, and it will ask again to confirm, because once you submit all and finish, you cannot go back and change the answers. And if you turn in everything the way it is, you should get a perfect score, and the other topics will open up. So I'm getting back to the main page of Moodle, and you can see that, oh, I did not get a perfect score. It's either that or because it doesn't really actually make my student roll correctly. Was anyone following along and get access to the material? Okay.
Yeah.
So it worked.
Yeah.
Okay, good. All right, so we'll go to the first slide, which is getting started. Now, with each topic, I copied and pasted from the curriculum. So all this stuff here is copied and pasted from the curriculum. Introduction to programming, computer organization, operating system, machine language, high-level languages, and stuff like that. Those are the topics that I need to go over. And then the other one, which is this one here, is basically the amount of time in hours that we are supposed to spend to use the CLI command line interface to edit, compile, link, and execute a simple computer program. So that's how everything is organized. So we'll go to getting started. It's a little bit slow today. And I usually just kind of go over these links sequentially. So if you have time after today's class, you might want to go to the next few links that I'll be talking about next Monday, so that you know what I'll be talking about. It is really kind of helpful to know ahead of time what I'll be talking about. If you have any questions, write it down and make sure that I have all of those issues addressed in the next class. Yep.
Do you mind if I go get tissue real quick?
Say again?
Do you mind if I go get tissue real quick?
No, go ahead. Right, so we'll start with low-level mechanisms and representation. This is actually a slide that I borrowed from my cisp310 class, which is the next class that you can take after this one. I'm not gonna expecting everyone in this class to fully understand everything in this slide, but I do want you to get a general idea of what is really at the bottom level of computers. Okay, and by the way, how many people have watched the Imitation Game? Okay, what is that movie about?
First computer.
About the first modern computer. There were mechanical computers before that, and about who's the main character? Alan Turing. And why do you think Alan Turing is important in a class like this? Who's Alan Turing?
Father of computer science.
The father of computer science. Without Alan Turing, there would not be computers like we have today. Okay. So this is just a little brief history of mostly the hardware, not the software or the theory, but the hardware of computers. What is this? Looks like a light bulb to me. And this is a euro coin, so that will give you the scale of this thing. It's a vacuum tube. Okay, and people used to make computers out of vacuum tubes. So vacuum tubes were in use in the 1920s. The Colossus computer that Alan Turing helped design also used only vacuum tubes as components. So the computer was big, huge. Power consumption is like there's no tomorrow. I mean, it just consumes lots and lots of power, because vacuum tubes have heating elements in order for it to work. Okay, so it takes up a lot of power, and it's huge. It's really big. And then people move on to transistors. Okay, transistors are based on semiconductor. Basically, what people do is they dope silicon with what we call impurities in double quotes, and that will make N material and P material. And then when you have those two material next to each other, you have a P-N junction. And that's basically the most important part of a bijunction transistor, BJT. And then later on we have MOSFETs, or field effect transistors. They work slightly differently, but for the most part, they're basically like switches. But they're still pretty big. I mean, if you look at this thing here, this is what we call a SOT23 package. You can fit about, I would say about 12 or maybe 16 of those things on the fingernail of your pinky, which most people would consider pretty small. I mean, if you are to solder those things, you better not sneeze when you're soldering, because when you sneeze, some of those will disappear. Okay, but they're still pretty huge. Okay, in terms of physical size. What is the current size of a transistor in a Intel i5 processor? The current generation.
22 nanometers.
22 nanometer, but on the roadmap, they already have plans for how small of a transistor. 14. Yep. Now, how big is 14 nanometers? What is 1 nanometer, by the way?
Shared segments.
Okay, well, this is not going to be in the quiz, but I do want you guys to know the measuring units. Okay, so 1 kilo is 1,000, right? 1 divided by 1,000 is 1 milli, okay, which is 0.001 of something. Okay. The next one up is a million, which is an uppercase M. So that's 1 followed by 6 zeros. The other side, which is the reciprocal of 1 million, is 1 micro, which is the mu sign, is a Greek symbol, and it's 0.000001. The next one up is what? After a million is a billion, okay? So a billion is 1 followed by 9 zeros. And on the other side we have what? Nano. Yep. So which is a lowercase n, it is 0.0000001. So a nanometer is 1 billionth of a meter. How many of these transistors do you think you can fit across the cross-section of a single strand of hair? Let's just say lots. Okay? It is really surprising. I mean, if you think about it, this is really, really impressive, how transistors have shrunk in size only over the past, 50, 60 years. So then we have, integrated circuits, which means we put multiple transistors onto the same silicon die, and so the size of each transistor can continue to shrink, and we can pack more and more stuff onto the same die. This picture really shows you the scale of how small transistors, or the density of transistors, in a modern computer. So in 1971, the density has a unit of 2300. And I don't know, this is transistor count. Okay, so the number of transistors on a single die. And you may not be too impressed because this looks like a linear line. It's just a straight line. So what is so impressive about the straight line? But when you look at the scale of the y-axis, you will notice that it's not a linear scale. This is an exponential scale. So that means the size or the number of transistors that we pack onto one single die of an IC integrated circuit is growing exponentially. And anything that grows at an exponential rate is important. Okay, it is big, it's important. Okay, I did this yesterday with my other classes too. So if you compare a fighter plane from the end of World War II, okay, not counting the jet, okay, just like a Mustang. What is the top speed of a Mustang at the end of World War II? Just approximately.
5,000 knots.
Well, that's pretty fast. I think they're about half the speed of sound, so 0.5 Mach or so. And if you look at current generation top of the line, fighter jet, how fast can it go? 2 Machs, 3 or so. Okay, let's call it 3, which is kind of generous. So that means, when you look at fighter planes, at the end of World War II, they are 0.5 Mach. Currently, they are about Mach 3. So a 6-fold increase, which is not insignificant. That's a big deal. I mean, 6 times as fast as the other one. When you look at this, everything pales in this comparison. Okay, so that really shows you, where we're heading to, because people think Moore's law will kind of continue. Okay, in other words, the exponential growth has not stopped. We have not hit that limit yet. But regardless of the size and how many we can pack, each transistor is really just a valve. It is a switch. Okay, you give it a control signal, and you can use it to control. Okay, is this switch closed or is it open? I'm gonna skip this part here until we get to this picture. So this is a picture of a Nand Gate, and I have to go fix my notes here. I said this NOR gate is actually a Nand Gate. It's made out of 4 transistors. Q1, Q2, Q3, and Q4 are transistors. And it implements one particular, what we call a gate in a computer. And the gate is kind of the lowest, the smallest logical unit that people think of when they try to make a computer. Okay, are there any questions? So we are going from the smallest, the lowest level of devices, which are transistors, and we are transitioning into what we call gates. Okay, this is a logic gate. And from logic gates, this is a truth table, and we can connect logic gates in several ways to make bigger and bigger components. So that's basically the logical stuff, at the lowest level. This slide still have something else that we should know about too, in this class in cisp360. So I'm going to give you this picture and ask you, how many samurais are there? Seven, right? Okay, there are 7 samurais, and that's also why the name of the anime is called Samurai 7. Okay, it's a Japanese anime. It's kind of fun to watch. Okay, but what exactly is the word 7? It's a number, right? Okay, it's a number. But you know what? I can also refer to the number or the quantity of samurais as 111 in base 2, 21 in base 3, and 13 in base 4. I can change the base of the number system and still be able to represent the same quantity. Okay, so hold on a second here. Okay, what exactly does that mean? I mean, 7 is 7. I know how to write 7 and spell 7, and that's the only way to represent 1, 2, 3, 4, 5, 6, 7. What about 111 in base 2? I mean, it doesn't make any sense to me. Okay, so let's kind of hold that thought for a moment and look at this picture. Okay, how would you describe the emotion usually, associated with this picture? It's a happy face, right? Okay. Well, to you it's a happy face, but depending on the language that you're familiar with, you can also refer to it as this, which is Chinese. You can refer to it as this, which is Russian. You can refer to it as this, which is Japanese. You can refer to it as this, which is Vietnamese, and Spanish. Okay, so they are basically, so why do we have so many different ways to refer to the emotion associated with this happy face? It's just different languages, right? Okay, so in the end, these things is really just a symbol to represent something that is an emotion. Is that okay? And why do we need words like these? Happy, H-A-P-P-Y. What is the purpose of words? I mean, I'm using a lot of words, right? So what is the purpose? It's for communicating, right? So 7 as a symbol is nothing more than a symbolic thing so that you can tell somebody else what is the quantity of blah, blah, blah. Okay? And there's no limitation that has to be the only way to represent a particular quantity. There can be an infinite number of representation of the same quantity. It's just like there are different ways to refer to the very same emotion represented by this little picture here. Are we still doing okay so far that we can represent the same quantity using different symbols? Is that okay? All right. So what we're going to do next is to talk about base conversion. How many people already know about base conversion? Okay. And what do you know about base conversion? Sorry?
It's possible.
It's possible? Well, not only is it possible, it is easy. Okay. So instead of reading all this stuff here, so I'm going to hide it and show just the happy face because we like the happy face. How many people think that you would be able to work at McDonald's as the person who's making change and giving people the change? You think you can do that? How many people do not feel comfortable? Yeah, may not be the best kind of thing that I can do. Okay. So if you look at the denominations of US currency, just look at the most popular ones. Let's name those things. Okay, it's on the slide already, but I want to put it on the whiteboard just to be sure that we know what we're talking about. Okay, so let's start with the dollar bill. Okay, so that's fairly common. I know we have $2 bills, but they're not common. Okay, so let's move on to the next popular one. What is the next denomination? The $5 bill, okay, fairly common. The next one is 10. Next one is 20, 50, and then we get to the kind of, wow, that's $100. Okay, what about the other side? From $1, we do have half-dollar coins, but they are not really usual. They're not common. So what would be the next one that is common?
Quarter.
A quarter. Okay. Quarter is 0.25, and then the next one is. Sorry. A dime, which is 0.10, and then the next one is a nickel, and the next one is a penny. Okay. Do you see any particular repeating patterns with the multipliers from one denomination to the next? Nope. There's no pattern. There's no repeating pattern. And yet, you can deal with it. Right? You deal with it on a daily basis. That makes it easy for you to learn base conversion. because you already know this stuff. You just have to reframe what you do with money, and then it's easy to do the conversion. Okay? So what do I mean by that? Okay? So the conversion means, okay, this is what we have, which is actually, you think it is natural and is intuitive. It's because you have been using it for many, many, many years. Okay? That's why you feel familiar with all of these amounts. But if you think about it, what if I give you a system where there are $1 bills, $2 bills, the next one up is 4, 8, 16, 32, 64, 128, and then on the other side we have half, quarter, and probably an $1/8. Okay? Okay, so think about it this way. These are the bills and coins that you can have. Can you, use some extra time? Can you come up with a particular amount using these particular bills and coins? That really is the question. If you can do it, you know base conversion. Well, let's give it a try. Okay, let's give it a try. Let's try out. I'm gonna erase this part here. Let's try $154.75, which is actually on my notes. So I'm going to use exactly the same amount. So with the usual, bills and coins, we know it's a $100 bill, $150 bill, 4 $1 bills, and 3 quarters. Okay, that's easy. What about using the new system? Okay, everything is a power of 2, right? 1 is a power of 2. It is 2 to the power of 0. What about an 1/8? That doesn't sound like a power of 2. An 1/8 is 2 to the power of what? -3. Okay? So there is definitely a regularity to this system. Everything is twice the amount of the previous one. Okay? That makes it easy to work with. Okay, so let's say this is the amount that you have to give somebody, and you want to use the least number of bills and coins. Okay, as usual. So how would you do it?
Give them a $128 bill.
Okay, 128,
Give them a $16 bill.
16,
An $8 bill.
uh-huh,
A $2 bill.
okay.
And then 3 25-cents.
Okay, well, maybe a $0.50 and then a $0.25. Okay? And you notice one thing is we either have something or we don't have something. The quantity is either between a 0 or 1. We never have 2 of something. We never have 3 of something. It's either just 1 or 0. Okay? All right. Well, that doesn't sound like base conversion to me, does it? Well, if this doesn't sound like base conversion, let's go back to this side and indicate how many of each type of bill or coins we have, in order to make up that much money. Okay, we got 0 of these. We got 1 of this, 1 of this. We don't have any $1 bills. We got 1 $2 bill, 0 $4 bills, 1 $8 bill, 1 16, 0 22, and 0 64, and 1 28. Is that okay so far? I'm just specifying the multiplier to each amount in order to add up to 154.75. Is that okay? Well, the binary number is here. You just have to tilt your head to read it. Like that. So you have a binary number, which is, you read it from the most significant digit to the least significant digit. So the binary number is 1001110.110. The point is always here. It is the separation between the non-fractional part from the fractional part. There we have it. This is a base 2 number. It represents exactly the same amount as 154.75 as a base 10 number. This is a base 2 number. So are there any questions about this base conversion process? Questions? Yep.
If it was like a base 3, would it be 1 3 6?
it will be powers of 3, so it will be 1, 3, 9,
Okay.
27, 81, and so on.
Okay, so but it always will start with 1.
Correct. Yep. Because any base to the power of 0 is 1.
Okay.
Yep. All right. So are there any questions about base conversion? Why do you think binary numbers are particularly useful in computer science? Because it only makes out of zeros and ones, but why do we like just zeros and ones? Why not use base 10? We got 10 fingers. Yep.
So you can have things be on and off to represent things.
Exactly. When you look at a logic gate, things are either on or off. Okay? So off usually means 0 and on usually means 1. So if internal to the computer everything is either on or off, a 0 or a 1, as a programmer, it is really helpful that we can represent stuff using only zeros and ones. And by the way, if a number system that only uses zeros and ones is called binary, exactly. All right. So, are there any questions about the stuff that I have talked about at this up to this point? No questions? Okay. If there are no questions, I'm going to move on to the next slide. This is not going to be a very formal slide. I'm not going to ask you guys to write out logic gates or design transistor stuff. Okay, so there's nothing like that. And let's see. I'm going to skip this one. I'll talk about it next time. And I'll skip over and talk about how we are going to do homework in this class because that's a pretty important topic. Okay, C and C++ programming can be done in a variety of environments using a variety of tools. Okay, and depending on which class you're taking, you're taking it from me, but if you talk to other students who take this class from Antos, Damon Antos, who else is teaching this class? Is Iraj teaching it? No? I think I remember there's one more person teaching this class besides me and Damon. But anyway, there are tools called IDEs, okay, Integrated Development Environment Tools. They are GUI tools. They're kind of nice because they seem easy to work with, okay. And then there are command line tools that I prefer, okay. The difference is like this, okay. How many people remember your dad using a manual drill? Remember those drills where there's a little crank and you have to do this in order to drill something? That's the kind of tool that I will be using in this class. It is called a command line interface tool. I'll show you, a little bit how to do it during the lab time. An IDE is like going to Home Depot and you go and you ask the associates and to say, show me the fanciest DeWalt power drill. Okay, you look at that drill. It's like, wow, it's got LED for the lighting. It has got lithium-ion batteries. It's got torque control, hammer drill, switches, and so on and so forth. Okay, that's your IDE. If you're starting out just learning how to drill and learning about material, having a DeWalt is not necessarily the best thing because it gives you 20 gazillion options to do stuff. But if you have a hand drill, okay, well, you will feel the resistance when you're drilling through different material, and you'll understand why you need to sharpen the bit when you're drilling something. When you use a DeWalt, you don't care. It's like, okay, it goes through anyway. Does that make any sense? Okay, so that's why I'm going to use command line tools and not IDE tools. It doesn't sound, it sounds really bad, it sounds really hard to use, but it's not, okay? It's just a matter of practice. And we'll be using it in a Linux environment, okay? So the tools that we'll be using in this class, there are 3 basic tools that we'll be using. The first one is an editor, a text editor, kind of like Notepad, except in this case, you can choose between Vim and one other tool which is called Nano. We have the compiler, which is GCC or G++, and we have a debugger called GDB. Okay, so this is the class where I'll be using a lot of GDB or the debugger, which is the best way to debug a program. I want you guys to walk out of this class knowing how to use a debugger as a tool to debug your programs, okay? Not using printf, not using cout. I mean, some people know kind of that stuff already. But there's a proper way to debug a program, and there's a not so proper way to debug a program. How your homework is going to be graded is based on your submission. So when you turn in your homework assignment, there will be some specifications that you have to follow. And these specifications will include the file format, file name, file path, extensions, and so on. There's a lot of details that you have to follow in order to turn in your homework assignment. And the reason why I have to specify all of these specifications is because your homework will be partially graded by a script. So what I do is I download a single zip file of all the submissions from this class. And I have a script that can automatically go through all of these programs, compile, link, and run with test cases. So if you do not follow these specifications, the script is not going to be able to pick it up and perform whatever is needed to grade it. Okay? Okay, but tech, that's just you being lazy and being way too picky. What do you think is going to happen when you learn a programming language and you say, you know what, a semicolon and a comma is about the same thing, I'll just pick one or the other. What do you think the compiler is going to say about that? Exactly. So if you want to talk about picky, I'm not even close to picky. A compiler is far more picky. What about when you get out to industry and you have to write a particular program to read a file of a particular format? And you say, you know what, this section here is supposed to be 256 bytes, but you know what, I think 300 is close enough. Do you think that file format is going to be compatible with the rest of the industry? Probably not. Okay, so that's why, being picky, quote unquote picky, or doing things according to specifications is really important in this particular industry. If you're in the art industry, okay, maybe it's not as important, okay? But in this particular industry, in computer science, electrical engineering, or computer engineering, it is really, really important, okay? All right, so now programs will be tested in my Linux environment, and I only use Linux in my classes, and I'll show you guys how to do it in about 10 minutes in the lab time, because most of you probably do not have Linux as your quote-unquote default environment or default operating system, and there's an easy way to use Linux for this class. You don't have to install anything. If you have a thumb drive with you right now that has at least about 3 gigabytes of free space, you can actually do the next homework assignment during the next 1 hour and a half. How many people have a external hard drive or thumb drive that has about 3 gigs left? So you guys can actually do the homework. You can install what we call a virtual machine and be able to get the homework done within the next hour or so. Okay. How big are external drives these days? USB thumb drives or SD cards? What is the quote unquote default size?
You can get 32 pretty cheap.
Sorry?
You can get 32 pretty cheap.
32 is pretty inexpensive, huh? Okay. So this will only take up 3 gigabytes, which is nothing. 10 years ago, if you talk about like this would use up 3 gigabytes, people would look at you like, I don't have that much space, not even on my hard drive. All right, well, it is 10:20, so I'm gonna stop the lecture. You guys can go out, take a break, and then in 10 minutes at 10:30, I'm gonna restart the recorder to record the lab portion of this class.